Hi, I'm Keenan with GreenGo Solar Wholesale Distribution. I just thought I'd show you something we got here real quick. We just got this inverter in for repair, and it has a note on top of it that says that there's continuity between AC1 out line and neutral. And the report that we got from the place that sent it to us had some little bit contradictory information. So we're trying to figure out what the fault is, but it's saying that it's a continuity problem. So I've got my continuity tester here, and we can see that indeed AC out 1, there is continuity between line and neutral. So it is as described. And there is no continuity between neutral and ground currently. Where's ground? On some, there's no continuity here. Some of these equipment that will say ground and some will say PE for potential earth. So let's go to the whiteboard and see what's going on. So this here is a diagram of the internals of an inverter. Of course, there's a lot of things missing, but your basic topology for all of your low frequency inverters, like your Victron, Outback, and all of those. This one is specifically for Victron, but it's all very similar. You've got your battery that goes to a power board in DC power that's converting to a low voltage AC, going to the transformer, which is converting that low voltage AC to high voltage AC, and that connects to your line and neutral output. So when the inverter is turned off, your line and neutral are often connected directly to the transformer still. There may be some inverters that have a contactor here, but generally speaking, that's still connected. So if your power is off, if your inverter is turned off, then that's disconnected. Now there's no AC in the system. The way that a transformer works, it's important to know the way the transformer works before we go into the next thing. The way the transformer works is when you apply the AC voltage to this side, it's creating this magnetic field, which is then creating the magnetic field over here, which is then creating this voltage. And so when it's all turned off and there's no magnetic fields, all this is a coil of wire. And so if you put your continuity tester between line and neutral, there will be continuity because it's just that free coil of wire. There's no voltages being pushed anywhere, no magnetic fields blocking the flow of current. So it's just normal. It's perfectly normal to have continuity between neutral and line when the inverter is turned off. When the inverter is turned on, you'll have voltage, 120 volts between neutral and line. And in that case, you do not want to put your meter in continuity because meters in continuity mode do not work when there's voltage applied. And there's a little bit more in depth on the topology. When the inverter is turned off, the Victron specifically, there's this contactor that connects neutral to ground, potential earth. And when it's off, that contactor is open, so there's no continuity here. When you turn the whole system on, you can change the programming, but default programming is that if there's no AC input, that contactor closes, and then now there would be continuity between ground and neutral. And we have tested that on this inverter, and that's working fine. Now, also, if you put AC input to here, then the inverter is going to assume that whatever source you're tying into this generator, or whatever source like a generator that you're tying into this inverter, that it's already connecting neutral and ground upstream in that source. And so when these contacts close to connect that power source, this contact opens. So this is not producing a path between neutral and ground anymore. It's assumed that that's going to happen upstream. I hope that that's helpful for understanding why there's continuity. If you see continuity on your inverter before or in the wires before you power it on, that's perfectly normal. That doesn't mean there's a short circuit or any kind of a problem like that. It's just normal.